Assignment 15, the intermediate value theorem. Or, as I will refer to it a lot of times when I'm writing it, IVT. Okay, so when given a continuous function, we'll call that function f, and a value of y, between two outputs, f of a and f of b, how do you find a value of x equals c between a and b for which f of c equals y? I'm going to draw a graph so this will all make a lot more sense in a second. All right, so the intermediate value theorem. States something. I'm going to go ahead and draw a graph to help make a little bit more sense out of everything that we're talking about here. I'm just going to draw it in the first quadrant. It doesn't need to be too elaborate. So I'm going to have some polynomial function that is continuous because all polynomials are continuous. And it's going to be continuous from a to b. And there's going to be some value in between a and b, and we'll call that c. So wherever I put a in, I'm going to have an output that is f of a. And wherever I put b in, there's going to be some output that is f of b. And all that the intermediate value theorem is saying is that if this is true, if these are my two endpoints, let's just think of in this interval, then that means that there's going to be some y value in between f of a and f of b, so some output that is basically going to equal once I put this input into the function, right, there's going to be an output that goes with this input. This input is in between my two inputs here. So therefore the output, f of c, has to be in between f of a and f of b. Now I don't think I did a good job on this, because if I do this, I think it comes over here a bit more. So I need to go up a little bit. So we know that there will be an output, f of c, and vice versa. If I know my two outputs, and I know that there's an output in between those two outputs, well, that means then that the input for this output has to be somewhere in between the two inputs that went with these two outputs. It's very simple. It's not any harder than that. So I know you're thinking to yourself like, that's obvious. Okay, but maybe pause the video for a second and just make sure that you can explain that. Okay? And now we're going to actually give the definition. So we'll say if function f is continuous, and by the way, all polynomial functions are continuous, so you might want to put a note here. All polynomial functions, so not rational, but all polynomial functions, so the rational were the ones with the fractions, but all other polynomial functions are continuous. All right, so if function f is continuous for all x values in the closed interval. Closed interval means that the endpoints are included. Okay, so we would include a in there and we would include b in there. Okay, so in the closed interval, and that's why we use brackets to denote that. Right, we're saying that a is included in this, and so is b. And y is a number between f of a and f of b, just like our graph is showing, right? Y is some number between f of a and f of b. Then there is a number x equals c in the open interval now. This does not include a and b. A and b cannot be that number x equals c, okay, because that's on the outsides. So open interval means that it doesn't include these ends, so we put parentheses. For which f of c equals y. Okay, and I'm going to do an example with you. I'm going to do it on the other side of the page because it looks like it's going to take up a little bit of room. So example 1, we are given a function. It's a polynomial function. We need to use the intermediate value theorem to conclude there is a value x equals c between the numbers 0 and 1 for which f of c is exactly equal to 1. And we'll find this value. So we're going to use the intermediate value theorem, okay, to conclude these things, okay, and then to find the value. So first of all, let's look back at the intermediate value theorem. So first of all, it says if function f is continuous. Okay, so that's the first piece of information that we need to look up. Okay, is function f continuous? So that's the first thing we're going to do. We are going to check the continuity. Well, we know that f of x is a polynomial. Again, it's not a rational function, which means there's no denominator. So we know then if it is a polynomial function, Therefore, it is continuous. So we check the first part of that. The second part of the intermediate value theorem states that if I know that I have these inputs, right, then there's going to be some number in between those two inputs for which f of c is some output, right? Because each one of these inputs gives me some different outputs, okay? And so I'm looking for, well, there's some value c that's going to give me some number in between these two outputs. Okay, so my inputs that I care about happen to be between 0 and 1. Okay, so we need to find a value in between 0 and 1 and in between those two outputs, so f of 0 and f of 1. So the first thing I'm going to do is I'm going to check my endpoints. So what is f of 1 and what is f of 0? Okay, so just plugging back into here, so that's going to be 1 minus 3 minus 6 plus 8. So negative 2, negative 8 plus 8 is going to give me 0. And then I also need f of 0. So let's see, f of 0, 0, 0, 0, that's just going to give me 8. So I know that all of my inputs do have outputs, and I know that my outputs have to be somewhere between 0 and 8. So I do know that the intermediate value theorem does apply. Okay, so the rest of this is, well, I need to figure out some x in between 0 and 1 for which f of c is exactly equal to 1. Okay, so my f of c is in between these two, right? It needs to equal 1. Okay, and I need to figure out which x value is going to give us that. So a good way to do this is to graph it. Or at least it's one way to do it. All right, so I'm actually going to go, let's see, so this is x, this is f of x. So I know that a is here. I know that b is 1, so that's going to be my b. Okay, and then I know that my outputs, well, when I plug in a, which happens to be 0, well, I know that I get 8 out. Let's see, 2, 4, 6, 8. So this is f of a. And I know when I plug b in, or 1, I get 0. So this right here, this is f of b. I shouldn't say right there. This point right here, my output is f of b, which happens to be 0. Okay, I'm going to graph this so that I have an idea of what the rest of this thing looks like. I'm just going to turn it on first. And my window, I just care about it being between 0 and 1. Probably way too big on the y max because it looks like my tallest it could be is 8. Right? That was my f of a. So it's looking something like that. Kind of curved a little bit. Okay. Let's See, so I just drew that. Sorry, you couldn't see that because it was behind the calculator. So kind of curved. Now, the question is, my output, I want to be 1. So this is going to be f of c right here. So what value on the x-axis am I when f of c is 1? Well, another great way to do this, yeah, you can trace along, but another really great way to do this is to go into y equals and put one more equation and make that equation y equals 1. And then we can look for where they intersect. So let's graph that. And then I'm going to calculate my intersection. First curve, second curve, best guess. So I'm getting x equals 0.8887 when y equals 1. So that tells me that this point right here is 0.88788838, sorry, and y equals 1. So basically my c here, this is c, and that's going to be 0.8887. Okay, so c is approximately this, which happens to fall in between 0 and 1, or my a and my b. Make sure that you can check that the intermediate value theorem applies by checking for continuity and checking the endpoints, okay? So figure out, hey, what are my a and b, and plug those into the function so that you can get what your f of a and f of b are. All right, that's it.